Hi, I'm Ryan, and this is my STM32 based embedded weather station written in C++. On boot up, the home screen is displayed on the OLED interface. This screen simply shows the live temperature and humidity data measured by the sensor. The user uses the rotary encoder to navigate through the interface. To start, I navigate to the log config screen to set up logging. From this screen, the user can configure how often the system logs weather data. The logger can also be enabled and disabled here. For this demonstration, I set the interval to just 1 minute and enabled logging so that we can take a look at a decent sample size later on. While the logger is logging every minute, let's take a look at the alert system. The user can configure these settings by navigating to Temp Alerts and Hum Alerts. Here, I select Temp Alerts. On this screen, the user can configure when the alert system goes off based on temperature readings. I set the max temperature to 73 degrees Fahrenheit. I leave the minimum temperature at 0 for now, and then I enable temperature alerts. We can see that currently the temperature is just below our 73-degree maximum. By lightly pressing my finger on the sensor, I'm able to increase the temperature slightly, which sets the alarm off immediately. Once I remove my finger from the sensor, the temperature gradually drops back down. Here, with some editing magic, I skip to where the buzzer is about to stop beeping. The alarm continued briefly once 73.0 degrees was displayed because the displayed value is rounded, while the alert system uses the full sensor reading internally. The system also includes peripheral health monitoring to ensure that the devices are working properly. Currently, all devices are wired and functioning, which is why the term System OK is shown at the top of the OLED display. Here I remove the RTC from the breadboard, and we can see that the top of the display immediately changes to Air CL, CL referring to the clock. By plugging the RTC back into the breadboard, I'm able to restore the system to a healthy state. We can see the same thing happen when I remove the sensor from the board, just with a different error code. We can also see that the entire home screen changes to say sensor error because there is no longer any weather data being gathered. Once again, I reinsert the missing component and the system returns to a healthy state. To finish up this demonstration, let's look at the gathered logs. I've inserted the SD card into my computer and can now view its log file. As you can see, we have several logs here taken over the last 9 minutes or so, each exactly 1 minute apart. Each log shows the date and time in 24-hour format, along with the weather data at that time. That concludes the demonstration of my STM32 based embedded weather station. Through this project, I gained experience designing an embedded system around multiple peripherals and developing custom hardware drivers from datasheet specifications. Thanks for watching.